Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
Where to start?
Dependency injection.
Okay, we'll tackle the big topic first.
Why not?
Yes, so one of the things I've started doing with these topics, because I feel like it gets skipped over, is asking what problem are we solving? So what problem do we solve with dependency injection? I think often people quickly jump to the mechanics of it.
Mm-hmm.
And so you're supposed to somehow know why you're doing this. And I don't understand why are we doing. I mean, it feels like some kind of it's a configuration thing. It's some kind of, it's more dynamic, but you're arguing that it doesn't have to be. So anyway, what problem are we solving?
We oftentimes we need things in our code. So we have something
back
that
to the basics. We
something
need things
else
in our code.
We need things in our code.
Okay.
We have something that depends on or needs something else in order to function. Okay.
I usually just import something and then use that thing. So.
Yes. And you can do that.
Mm-hmm.
But here's I think the core of the why with dependency injection is that what if that thing that you need can change?
Not an uncommon situation.
Yeah. And what if it can change in a variety of ways? So what if it changes based on the way that I'm running something? So this could be that I need something different if I'm doing local development versus I need something different if I'm running a test versus I need something different if I'm running a production.
Mm-hmm.
So the environment can determine how the thing that you need changes.
Okay.
But then also configuration can determine that thing, and it can change based on configuration that's provided to the application. So there's a variety of different ways that, another common way that things can change is based on what else exists in a system can then determine how it changes as well. So you can almost see it as like a hierarchy where as I am constructing all of the things that everything needs to run, that's making some decisions about what is being provided. And then those decisions impact other decisions for what gets provided and provided to something.
Okay. So can you give me the most common example?
Database stuff.
Okay.
So I've got a DAO, for lack of a better word, a database access object, some place in my code where I'm going to be able to say, get me all the people from the database.
Mm-hmm.
And so my DAO, it has a dependency on something that actually knows how to talk to a database. And
so it's like a facade between you and the database.
Yeah. And, it's providing some logic in some way, that some reason for abstracting out those two different pieces. And so I've got my facade, let's call it, and I've got my actual thing that talks to the database, my data access object or whatever. And I have intentionally decoupled those, but my facade has a dependency on my DAO. Mm-hmm. Okay. So you certainly could just explicitly provide that DAO. You could create an instance of your DAO and provide that. And that's fine.
Which, if all you were doing was abstracting away from the database, would make sense, not generalize. But right. Clearly this must happen in other situations as well.
Yeah. And so now, let's say that our DAO can change.
Mhm.
that maybe when we're doing local development, I think this is a horrible practice, but a lot of people do it, is maybe you want to use a H2 in-memory database. And then when you're running your tests, you maybe want to use a test container. And then when you're running in production, you're going to use your like actual production DAO or whatever. So now my DAO is changing across those environments, or maybe it's changing based on the configuration that I've provided to the application or whatever. So the thing that I am providing, the way that I'm getting my dependency is going to change in a variety of ways and depending on a variety of factors. So the whole thing of dependency injection is just giving you a facility to provide those dependencies, provide that construction and injection of dependencies based on this graph that it determines.
So as your system is kind of waking up and seeing what the environment is and doing it, so it's going, oh, I have this, I better grab that.
Yep.
And because that's the situation here, and I have this other thing, so I'll grab. So it's waking up and making all these choices as it's basically constructing itself.
Yep.
Okay.
Yep. Yeah. And so in Spring, the most common Java dependency injection framework, it is doing this primarily through something that's called a context. Mm-hmm. And so you have a Spring context, which is your dependency injection context. And I believe that Juice has the same model, where there's this context that is keeping track of everything. And it's making that whole graph of decisions and injecting things. There's also a life cycle element to this, where sometimes when you inject something, you want to inject a new one every time that it's needed. And sometimes you want to have a singleton. And so you inject the same instance every time. And so dependency injection frameworks also have a concept of a life cycle. So the context is what's keeping track of the state of things and the graph and dealing with like circular dependencies. And, there's all sorts of things that context is managing for you.
And presumably the context isn't just like a configuration file or something. It's an active object that's checking out the environment and making decisions for you.
It is somewhat single direction oriented in that you construct your context and then you ask the context to give you something. And typically in the world of Spring, this is all just done with annotations. And so you annotate something as needing having a dependency on something, and then out of the seemingly ether, it pulls that. But really what that's doing is it's going into the context, pulling the thing out of the context and giving it to you. So
the context is really, I don't know, I want to say running things, or I mean, it's the point of, I guess, the point of truth. You go, okay, I need to do this thing. I better go ask the context, and the context is going to hand.
You should never do things out of the context, because then you're bypassing the state of the world, and you're screwing up that state. And so, yes, whenever you go get an object that uses dependency injection, you need to go to the context to get it.
So the context is almost like a factory
it's just like a stateful factory.
Okay.
Yep.
Huh.
Yeah. And so Spring started with using XML to configure the wiring. And so you'd have your XML that was for your local dev that defined the structure of how things came together and the different ways that your graph of dependencies
could change. Was just a static configuration file.
It was, yeah.
Mm-hmm. And you'd use a different file depending on the situation you were trying.
So you'd have an XML file for your test when you run your test, and you'd have an XML file for your prod. And then Spring, you can still, I think, use the XML stuff, but nobody really does. So then Spring added support for doing this with annotations instead. But back to the XML file. So when you would start your Spring application, the context would go read your XML file and determine its graph of dependencies.
So the context was a lot simpler because it was just relying on this static XML file.
It was just externalizing,
Mm-hmm.
the dependency information to an XML
And it
file.
wasn't really dynamic in that case. It wasn't. It was.
There was some ability to have dynamic stuff, but yeah, I don't remember exactly how that worked.
Which is probably what started pushing it towards dependency injection.
I mean, it was dependency injection with the
Mm-hmm.
XML one, in the fact
Mm-hmm.
that the other name, I don't know if I've said it yet, is inversion of control. That was the
Mm-hmm.
original name for dependency injection. And I'm sure that Martin Fowler coined that one like he coins everything. But so inversion of control was in some ways a better representation of what's happening, in that it used to be that you would instantiate an object and pass an instance explicitly to the thing that needed it. And instead, the inversion of control inverted that model and said, no, there's going to be this context that is going to give you what you need, the dependencies you need, instead of you explicitly passing them.
I can see. Yeah, I feel like when I came across that term initially, I found it a little confusing, and I still do, because it doesn't feel inverted. It just feels um, uh, put. It's over here now instead of me making that decision.
Yeah, it's
So I
true.
think I was always looking for what's the inversion.
Yeah, it's true. It wasn't quite an inversion. It was more just a shift left of
Mm-hmm.
the. It's a shift left control, not an inversion control.
Mm-hmm. Yeah. Okay. So
most of the dependency injection stuff in the last like 10 years on the JVM used annotations as the way to describe the wiring.
Mm-hmm. And the annotation simply says, I need a thing, but always go to the context to get this thing. And here's the name of the thing, but get it from the context.
Yeah. Yep.
Okay.
Yeah. And so you would have some way to create the context, and your kind of entry point into your application needs to be something that you get out of the context, because you need to have that like first thing. Like you create a context, but then the thing that you interact with, your endpoint you interact with, your server that you're starting, whatever, needs to come out of that context,
Mm-hmm.
because then everything else follows underneath that, where everything else every dependency in the whole graph of dependencies is then using the context to get its instance.
And the context, I assume, is always a singleton? Or would you ever have multiple contexts?
You can create multiple. Like, this is something most people don't have to actually do, because it's all kind of hidden from you and abstracted in a way that you don't have to think about it. Mm-hmm. But you can create as many contexts as you want, and you can provide different configuration to the context creator. Context, there's some way to create an actual context, and so you can give it information about that. Then it will determine the graph that it creates from your configuration. Most of the time you don't have to do that. Most of the time you just say, run my application, and underneath the covers it's creating the context and doing all that for you. But so most Java based library dependency injection frameworks used annotations, which then uses reflection.
Oh, and wait, remind me, you do like reflection?
Oh, it's
because it makes everything horrible. So flexible.
It's so horrible. So when they switched to annotations, they had to have some way to, at runtime, be able to modify things, mm-hmm. and modify basically arbitrary things. And so, yeah,
sounds like reflection.
Reflection was the way, and
go to.
And now it's causing a whole lot of problems with ahead of time compilation and GraalVM native image. And so there's this whole effort right now to like make reflection easier in ahead of time compiled scenarios. When I'm like, could we just not use reflection for this thing? But anyways, that's a separate topic.
It's funny how something that seems like the obvious path, and it works for a while, and then we begin running into more and more edge cases, and then we have to go back and go, oh, that thing that seemed like a good idea, it actually isn't. But we could only figure it out by building systems that were big enough to demonstrate that.
Yeah.
But in the small, I mean, it's kind of like exceptions.
Yeah.
In the small, they seem like the smart thing to do. But then as the systems get bigger and bigger, we begin to discover the problems, but they're not obvious. They're subtle.
Yeah.
And to actually track it back to, oh, it's because we're using exceptions in this way.
Right.
That's what the problem is. So we have to shift our fundamental understanding. We have a whole bunch of people at that point who have gotten on board with that fundamental understanding. And then you come along and go, we shouldn't use reflection for dependency injection. And people go, works for me.
Right.
What's your problem?
Yeah. Yeah. I mean, there's two ways you can go with it. One, you can try to build a layer on top of the thing to make it better. Or you can,
that's the additive approach, right?
That's right. That's the additive approach. Or you can say, maybe the foundation that we've built on is not the right foundation for this. I had a tweet about this exact topic where I said, this was just like yesterday, where I said, better DX isn't just adding tooling
developer
to make
experience.
Yes, right, thank you. So better developer experience isn't just adding tooling to make something easier. Often better developer experience is taking something away so it's no longer needed. And then someone followed up with a much better way to say this, but let's see, who is this person's? Benjamin Black says some rules for engineering and operations. And the first one is, the best solution to a problem is to not have it. And just so nails that concept of, sure, we can make reflection work. And we can do all these like gymnastics to make it work in all the places that it causes issues, ahead of time compilation being one, startup performance being another. We can do all these gymnastics to continue to try to make reflection work, or we could just say, let's not use reflection and get rid of a whole set of problems. So the Spring folks, they're using reflection. And I use Spring, and I certainly make trade-offs with my ideals.
Well, and it works until it doesn't.
That's right. Exactly. It works until it doesn't. But so Micronaut took a different approach with this, which is they wanted to have the programming model of annotation-based dependency injection, to primarily, I think, because it is familiar to a lot of developers. But they didn't want to use annotations. And so they actually used the Kotlin annotation processor, CAPT, to at compile time process their annotations. And so Micronaut in some ways can work a lot better with ahead of time compilation and doesn't have the startup overhead of reflection and all these
which
sorts of
you
things.
didn't mention. So when you're doing dependency injection, there must be some amount of startup overhead. Is it significant?
It can be, and it depends on how many classes you have, because part of doing reflection and figuring out that graph at startup time is going and looking at every class in the system and looking at the annotations that are on all those classes. And so there's this overhead to scanning the class path. So larger the class path, the more
But how
scanning.
often do you start up a system?
So yeah, certainly it depends on your use case. If you're building a command line, you probably don't want to wait for that whole scan to happen. If instead you are building a server that you're going to start once and it's going to run for 5 years, then yeah, who cares?
But
if you're serverless, exactly, then you do care. And so that's where Micronaut has fit generally better with GraalVM native image, has fit better with serverless. Some of that stuff is because they're not doing the stuff at startup time.
And in that case, startup time really is important.
Yeah.
Because every time you hit a serverless thing, it has to start
cold
up
starts.
your system.
That's right.
Yeah.
You get cold starts. So this is all kind of traditional model of how we wire together applications. And there is some nice things about it. If you're working on a large team, let's say you've got 1,000 developers all working on a code base, it is pretty nice to just decouple all these things, and everyone is creating their beans and putting them there. And then anytime you need a bean, you just say, all right, inject me that bean.
So you actually go to the context to get a bean.
Yeah, that's the dependency injection. And bean is like the terminology of spring beans and all that. And so a bean is something that can be injected. And so if you're working on this large project where every person, all of your 1,000 developers are just creating beans, then that makes it so anyone can say summon from the ether, which is really just the context, but that's abstracted from you. Say, I need a foo bean, and
we're talking just like data classes here. And in other words, yeah, I mean any kind of bean, including just data transfer object or whatever. I'd go to the context to get that.
Anytime you are constructing something that has dependencies is when you would make it a bean.
Okay.
If it doesn't have dependencies, then just construct it with a constructor. Don't
go to the context.
Yeah. You don't need the overhead of it.
Just double check it.
Yeah. It's a good question. Is like, when should something be a bean or not? And it's if it has dependencies or it needs to be injected. But the only reason you would need to inject it is if it has dependencies. So
it's a little confusing because we have Java beans.
Yeah.
And you're not talking about just plain old Java beans. You're talking about
injectable things.
Okay.
Yeah. Yeah. So there is a nice thing about this, like just summon any bean from the ether, and in a very large team working on a shared code base, it's pretty nice to just not have to think about where that thing comes from, how it's configured, how it's provided, any of that. You just say, give one to me, and you
the
get one.
factory. It's almost too bad they didn't call it a factory.
Yeah.
Because I find that the factory model is a pretty useful one. It's one of the few design patterns that like you can see universally used.
Yeah. So there is a different way that you can go with dependency injection.
Okay.
And this is
other than the Micronaut way, or are you talking?
Yeah, other than the Micronaut way. Okay. So most of the dependency injection stuff in Java basically looks the same. It's annotation based. May or may not use reflection to do that, but annotation based programming. And the programming model it's not that bad, like with the annotations, until, like you said, until it is bad, and then it becomes a whole lot of fun.
Then you hit a wall.
Yeah,
like so many of our programming systems, it's like, it works great. Oh shoot, it doesn't work great.
Yeah,
and the only thing we can do is change at a fundamental level.
Yeah,
which is expensive.
Yes. Yeah, and so on the functional programming side of things, it's interesting because for a long time, people were trying to kind of recreate the programming models, the dependency injection programming models for functional programming. And there was a bunch of attempts at this. Dick Wall, our friend, created one. And,
yes, I remember that.
Play Framework just used like the Juice dependency injection stuff. And so there's been all these attempts to like do dependency injection in the world of functional programming. And I think they've all failed because it didn't give you the benefits of functional programming. One of the benefits of functional programming is pure functions. For every given input there, it will always return the same thing.
But every time you go to the context, you're getting an object.
That's right. With dependency injection, you inherently cannot have pure functions. It is impossible because you've got some external thing that is stateful and giving you potentially something different every time.
But what you get from the context is something that has both state and behavior, right?
Yeah.
I mean, isn't that necessary? So, which is basically the meaning of an object. It has state and it has behavior.
Yeah.
Okay. So what's your solution here?
So the solution, which there's been, again, a number of attempts at doing this in a more functional way, the problem is the same. And the problem that's trying to solve is the same thing we started with, which is things can change.
Mm-hmm.
And I need to have a way to provide different things to things that have dependencies. And so, but can we do that in a way that is pure functional? And so mostly when I've done this, I've used Scala Zio as the way to handle this. And the way that they do it is they say, okay, we're going to have a core of pure functions. And so that means that, we've got referential transparency, where given an input, we're always going to get the same. You can, I think the actual definition is something like you can substitute giving a function an input and calculating its output. You can substitute that for the value. So that should always be substitutable. The computation of an input, a function with an input, should be substitutable with its value at any time.
Mm-hmm.
Okay. So what we're going to do is we're going to start with a core of things that are pure functions. And then at the end points of our application, anytime we touch the outside world, we're going to have this thin layer that says, all right, here's the place where we're going to weave together the actual pieces that our system needs. But inside of that, it's all pure functions. There's nothing that actually computes state. There's nothing that actually talks to the outside world. But at some point we need to materialize this into something that can talk to the real world and mutate state. And so we're going to have this just thin layer over our pure functions that provides that. And it does it at our endpoints. So an endpoint is, I'm going to start a server. I'm going to run a test. I'm going to start a command line, run a command line, whatever that may be. Those are our entry points. And when we have an entry point that touches the external world is when we're going to weave together all of the dependencies that are needed and pass them to that thing, so that then something can take our pure model and run our pure model with all of the dependencies that are actually needed. And so this is called an effect system, functional effects, and Zio is one option for how to do this. It's a very different programming model and way to think about the world, and it adds some complication. So I'll give you one just simple complication that this adds, and then I'll stop ranting. But so think about a random number generator. A random number generator can, by definition, not be a pure function because it's random. And so it is, for a given input, it's giving you a different output every time. It is talking to some external system, and that external system is indeterminate by definition. And so a random number generator cannot be a pure function. It cannot live in that nice pure function bubble. You can have a dependency on something that generates random numbers, but you can't actually generate a random number in that bubble of pure functions. And so if you had a program that needs a random number generator, then at your endpoint, where you're going to construct a program, is where you would say, okay, here is the thing that's actually going to generate random numbers. And you would then pass that into your functions, and your function would then be able to run with the thing that's actually going to talk to the outside world. Did any of that make any sense?
Yeah. No, and it reminded me of Elm, one of the trouble points that I had mentally with Elm, which is okay, we have a data structure which describes our system, and that's constant. And then we're getting ready to change the system, and the data structure, now we're going to generate a new, I think, identical one of those. I mean, not identical in terms of its values. We have this moment where we change the values, and now we have a new data structure, which we plug into this thing, which has to be a variable because it's changing from one data structure, one instance of that data structure to another. But I guess it's okay because we've isolated it and it's behind some, a curtain. So there's a little bit of magic.
I think it
happens.
can be immutable in the case of Elm. I think you can create a copy of your model, they call it, and then your model will be update. You'll update your model with the new value, and then you just return that.
Yes.
And the thing that is running, essentially the Elm effect system, or I think they call it a runtime in effect systems, the runtime is what is now saying, oh, I have a new model.
Exactly. But there is that moment, and underneath the covers, there's a variable that points to the model that switches from the old model to the new model. Now, Elm is managing that for you.
Oh, right. Yeah. So in the runtime, there is mutation. There
is mutation. I mean, they've narrowed it down to what is the model, and I'll switch from the old one to the new one, and we'll do it at this, behind the covers at this point where we decide, okay, now we're updating the model.
Yeah.
But it still bugged me a little because it's not, well, I guess it's what you're talking about with the effects. It's like at some point you're going to have things that are going to change, that are not, we cram them into a little box.
If you can't ever do mutation or talk to the outside world, then you have a worthless program.
Right. You have, it's kind of like pure math or whatever. Right. It's like, we've proved these things in pure math, but if we can at some point,
you have to talk to the outside world.
Talk to the world, which I think is important to say when we're talking about functional programming.
So in the case of Elm, the outside world, part of the outside world is your DOM. The browser page, and the DOM is mutable.
Right.
And so, yes, at some point, your Elm program that you've written all immutably and all that, at some point, ultimately, it has to mutate the DOM. There's no getting around that.
But it's doing, the system is doing the mutation for you.
That's right.
And you're, and I don't know. I think for my mental model, I needed to know that like sooner than, or I felt like they tried to hide it. They tried to go, oh no, everything is immutable.
Yeah.
You're going, is it though? And without really that explanation of, oh yeah, mutation happens, but we're controlling the heck out of it.
Yeah.
And that I think is necessary for a new programmer to kind of have.
I think we in programming, in the typical kind of mutable imperative model, we don't really think about things as there being a difference between the code that I write and the runtime that's actually then doing something with that. Whereas in Elm and in Zio and other effect systems, there is a very distinct separation between here's the description of my thing, and then here's the runtime that actually takes that description and actually applies it to the real world. And so it's a different mental model than what we're used to.
Yeah, and I think maybe we just haven't been doing it long enough to be able to understand that it's necessary to explain that. And also now the intent is different. It's like, yeah, we know things mutate, but what we're trying to do is isolate ourselves as much as possible from that mutation so that our code doesn't inherently have flaws in it.
Yeah.
And to be able to say that, I feel like makes more sense to people, because the first thing that they're going to say is, hey, the world changes and our model, well, it's like what you said in your tweet. It's like the model needs to, or did we talk about that already? Your tweet about trying to fit the model to the world or to our world. So I don't think we talked.
Yeah.
Okay.
Yeah.
And so
which one was that? This one. Okay, so one of the most important programming concepts I've learned in the past decade is how to better make my types reflect reality. Was it that one?
Yes, that's the one. And we were talking about, okay, so how that feels different than just saying, all right, we should do domain-driven design. Because with Eric Evans' book, he talks a lot about like literal real world stuff, the shipping example and the pieces in the shipping example, which is a nice entry to that idea. But what you're also talking about is on the, I guess I'll call it the internal model of our programming, like I call a function and the function may not return a value for some reason. And it's too easy to just say, let's pretend we're on the happy path and it does return a value every time. And yeah, problems might occur, but then we'll get an exception or whatever. Let's not worry about that.
Yeah.
And all the trouble that gets you into.
Yeah.
And so what we want is, no, we need an object that comes back that has potentially the value. And then if the value isn't there, something else tells me what's gone wrong, a default value.
That's right. Yeah.
Something.
Yeah.
That, yeah. And I think you were talking about how, for example, a way not to do this, you are arguing against, say, just returning a tuple.
Right. Yeah. So the example that I used in this tweet was, if something can return either an error or a value, don't return a tuple, because the tuple doesn't reflect the actual possible way that this thing can be. A tuple is something that can be inhabited by a two
multiple.
A two value tuple can have two values.
Well,
has two values. It
does. By definition, it has two values.
Yes.
And they're two they don't have to have any relationship with each other.
Yeah. But in the case of something that can only return either an error or a value, a tuple is the wrong way to model that, because you should have, back to ADTs, algebraic data types, which we've talked about a number of times, a sum type is the way to model something that can be either an A or a B or a C, or how many ever possible things you want. So, but a tuple is a product type, and so it just is.
By product type, you mean it has all of these things together.
That's right. Yeah.
Whereas what was the
sum type?
A sum type has only one of the possible things.
That's right.
Okay.
Yeah. Sum types are like enums, and product types are like data
and
classes.
Sum is SUM.
Yeah, that's right. Yeah.
Okay.
Yeah.
So, but from a kind of pragmatic standpoint, a tuple can work. I mean, that's how Go does it.
Yeah.
It's like, okay, you get a tuple back, and you can't just take the tuple and pass it to whatever's looking for it. You have to reach in and grab the result. And so it's kind of maybe a compromise.
I would say the way that Go does it is just mathematically flawed and logically flawed, because it's not the right data model. The right data model is, if something can return either an error or a value, it's a sum type, not a product. But Go makes it look like a product, but you're right that you don't really use it like a product.
And so it seems like they were saying, well, we can do this. It's kind of like using null to represent, something else happened than the result. And it's like, well, that happens. That's just, that's an implementation detail. The concept is, you didn't get what you were hoping for.
Yeah.
And we'll represent that by using null.
Yeah.
And here the concept is, well, we'll compromise and use this tuple rather than inventing a new type. That I don't know that it really helped, though, that much. I think they could have, because when you get a tuple, you have to write some code to unpack it before you call your next function.
Yeah.
And
you have to do that in Go.
Yeah, right. Exactly. That's what I mean.
You see all over Go. You see if error not equal nil.
Right. Exactly. And if they had maybe gone the extra step and said, all right, let's have every function return some kind of object, and it might have been probably would have been more efficient, wouldn't it?
I don't know.
If it was a sum type rather than a tuple. And I feel like they're worried about efficiency because they use tabs instead of spaces.
I think a possible valid concern with this is that it is a slippery slope, and you can see the slippery slope with Kotlin. Is that as soon as you say, all right, let's do a sum type for this. Then, well, you probably want that sum type to be like an actual sum type with like a sealed class where you have, it can only be these things, so it's sealed. Then you probably also want it to be a monad, because you can chain it and chain these monads across functions. And like, I can totally see.
And then you have to teach people what flat map does for every function that they call.
Yeah. And then your next slip down the slope is that, okay, now that we're using monads for these things, we probably need an effect system to like handle our monads that touch the outside world. And so eventually you just get to Zio, and which I love and think is the solution to all this.
But there's a learning. It's not a curve; it's a step function.
Yeah,
it's like suddenly you have to know all this stuff in order. And based on what Kotlin was trying to do, which was make a gentle transition, better than Scala, from Java to something that will work easily with Java.
Yeah,
that I understand their choice, but it does seem like at some point we need to rethink this, because there's still enough flaws and limitations to that model that we're gonna have problems with it. But I don't know. That's what C++ did. It said we want to be able to effortlessly bring people from C, so they can just program C, and then they can start slowly adding these features as they go. And that, bringing in the human psychology is remarkably
behavioral economics.
Yes, exactly. The behavioral economics aspect of programming languages.
Yeah.
And just pretending, well, we should go for perfection. Well, then you've got Haskell, but hardly anybody uses that.
Yeah.
So, and I think it's because of that mental model step function that you have to go through. And so maybe we need to.
So on the flip side of this, what happens with dependency injection and with Jetpack Compose, which is the UI programming model for the new one for Android.
And have you been using that?
Yeah.
And do you like it?
It's fine, but it's not what I want it to be.
That's what Shakespeare would call damning with faint praise. It's fine.
There are nice things about it, but it's one of those things where, to me, I'm like, okay, yes, monads are hard to learn, but monads would have been so much better of a model for this thing, because what happens with Jetpack Compose is that you need to mutate state. And we're not doing it with monads, and we're not doing it with pure functions, and we're not doing it with an effect system. Instead, you've got this magical, I think somewhere I call it like a magical lurking dragon of state like management that's happening somewhere else and happening in some way you can't comprehend. And so when things don't work as expected, all of a sudden you're like taking your sword into the cave looking for this dragon that's probably just going to eat you and spit you out after frying you with its fire-breathing mouth. And so yes, it's fine until it's not fine. And when it's not fine, you don't have a good model that you can drop down to. So there is a trade-off there. Yes, it is easier to initially learn, but once you need to go looking for that dragon, gosh, it's not going to be fun. And so I really wonder, and Elm was actually, I think, the first major system that said, okay, yes, we know there is going to be a higher learning curve to doing this. But we think that the benefits of helping people through that step function learning curve to understand a better way to do things is going to be worth it in the long run. And I guess if you look at Elm's current adoption, maybe this is telling me that, that I'm wrong and that it's not worth it, or maybe it wasn't worth it for Elm, or they didn't invest enough resources, or maybe we as a programming community weren't ready for it, or
when you think about the behavioral economics approach to things, which is kind of not for people who aren't familiar with the term, there's economics where my model is they go, wouldn't it be cool if we could write equations that predicted the world? Let's assume we can and go from there. And then behavioral economics came along and said, well, let's watch what people actually do and build our model on that.
Yeah.
And it's harder,
Yeah.
but it actually is a way better model that's more predictive. So if you look at, languages and our systems this way, then you have to say, yeah, everybody understands basically what an object is now. We can argue about whether that's a great thing or not. But when C++ was coming along, nobody knew what an object was or polymorphism or why you would do, why is this helpful? And so everybody had to kind of, or not everybody, some significant portion of the programming community had to get to a certain point of understanding of these concepts before we could introduce newer concepts. And so, Elm is ahead of the curve, but, C++ had to push the boundaries, and that's probably what Elm is doing for people. And so, maybe it doesn't have this massive adoption right now, but the people who do adopt it are beginning to learn why these things are valuable.
Maybe we're starting to see signs that the general developer community is becoming ready for some of these concepts. I just saw a tweet where somebody said that Scala Zio is like the first time in 10 years when they've enjoyed programming or something. And I see with Scala Zio, a lot of developers are looking at it and be like, okay, this is something that I can learn and can use and can enjoy programming with and can see the benefits of. Whereas Haskell, I think, was, it certainly helped push things forward, but most developers, and myself included, like Haskell is too far. Like I can't go that far. Not ready for that.
Like when I first saw Haskell, just the syntax of how you define a function was beyond my comprehension. Now, having seen parts of that syntax, go into places like Scala and Kotlin, and you go, oh yeah, this actually is a way better way of doing it, but it's just that little piece. And then I can go back to Haskell and I can go, oh yeah, I can read this now. And then there's some things that I learned from Elm that I can now look at Haskell and go, oh yeah, I can see why they're doing that. But having that dropped on you all at once, okay, everything's different.
Yeah.
And it's like, oh, it's overwhelming. Yeah. And you can't, we have to allow for incremental understanding. And I think part of what we're looking at, the motivation behind it, is we're making bigger and bigger systems. And when you have something like JavaScript, which is this huge free-for-all, and the system gets bigger, and then people go, oh, I can't manage the system anymore. Yeah. Something's gone wrong. And then they're able to go back and say, oh, I can see why these alternatives are coming up.
Yeah. I'm glad you brought up like refactoring and kind of evolvability of a code base, because that is one of the things where you don't see the impact of a model like a dynamic type system or or using an effect, not using an effect system or whatever. You don't see a lot of these impacts until you need to like evolve the code base, refactor it, add some feature, whatever.
And when it gets big too.
And when it gets big, that size also is a huge
which
factor
is
in this.
Kind of inevitable. I mean, we go, oh, I can do this now. Now add more and more stuff. And then you begin to hit the boundaries of what your system.
Yeah. The complexity overhead slows you down progressively.
Whereas in the small, it doesn't seem like it's a big deal.
Right. Yeah. And so like Python could be great for small stuff. And, I'm certainly people are using Python for large stuff too.
They make huge systems in
Python. I on the large code bases that I work on, I am so freaking thankful that the compiler tells me, yes, your refactor works or has some level of workiness to it.
Well, I think this is, the reason that optional static typing got its way into Python, because when we started dealing with bigger systems, that became
I heard the story. I need to look it up to see how valid it is. But I heard that the Microsoft team that was working on VS Code, they initially started with JavaScript, because they're for a variety of reasons.
I thought it was still in. Oh, it's in TypeScript now.
So once the code base got to, I don't know what the number was, 400,000 lines of code or whatever, they couldn't move forward anymore. Like you just could not validate that the program was correct. And so it got really hard to add new things to VS Code. Their velocity significantly slowed down as their JavaScript code base got large. Yeah. And so they went off and said, we're going to go create typed JavaScript, which became TypeScript.
So you think VS Code is the motivating factor?
That's the story that I have heard, is that the code base of VS Code that started in JavaScript got too large and the velocity got too slow. And so they went and created TypeScript so that they could move VS Code forward.
Yeah. Well, and I could see
it's a plausible story, right?
Oh, totally. I mean, because it isn't just a website, which might fail now and then, but whatever. And I could totally see, I mean, because with Python, people kept creating larger and larger projects, and the lack of typing becomes a problem.
Yeah.
And I realize in hindsight that, because I, for a long time, was arguing for, the way that Python worked and the problems with static type checking. And I realized that a lot of the problems that I had with it was the visual noise of static typing. But when you look at it just from the benefit standpoint, you go, okay, well, what if it wasn't awful to write and read this stuff? And it's like, well, you can't argue against the benefits.
Right.
And Scott Myers once told me, he goes, there's two benefits for static type checking. One is generating more efficient code. Well, that's hard to argue against that. And the second is tooling. So your tools can tell you things about it. And it's like, both of those are super good things.
Yeah. But there's a trade-off. Then you have to satisfy the compiler. You have to, you can't just do things, whatever
you want, which in most of the times in Python, you're not, but you don't have that extra
validation,
encumbrance or validation of the type checking. And so once you see it that way, you go, oh yeah, it's got benefits. And my problem was, Java mostly.
Yeah.
It's like having to repeat yourself and create this really hard thing to look at.
Yeah. And
they've been making progress, but it's still, I guess we have VARs now, but who knows what the limitations of those are.
Yeah. So to me, immutability, pure functions, effect systems, a lot of the benefit is exactly what we're talking about with type systems, is that when I'm writing my code, when I'm just just getting started on a new project, they may not have a lot of value initially and may actually be kind of annoying. But once the code base gets large or I haven't touched it in a long time, I need to go do a refactor, need to go add some new feature, I am so thankful that I started with those things. And so, I think I would throw effect systems into the same boat as type systems, and being like, it may be painful. I may not see the benefits of it right away, but down the road, I'm going to be so thankful that I built things in that way. Because you can say
it only changes it. All the variance happens here, right? In this place. So I can, whereas if you don't know that, you go, gee, I wonder where it's happening. I guess I'll have to go look for it.
Yeah.
So it's a benefit, and in 10 years, maybe that high percentage of people will be able to say, totally, I get it.
Yeah. I just had a project that I did a huge refactor on, totally changed the architecture of the application. It was a major overhaul. And it only took me a day to add this new feature, do this major overhaul. And the compiler validated, yes, your changes have compiled. And I was in production from the point that I got the compiler working to when I got that change in production was 10 minutes, because compiler gave me a thumbs up. let's deploy it and see what happens.
Mm-hmm.
And it
presumably your test cases also give you
in this code base, I have I have got like 2 tests. The compiler does most of my validation for me
on the compiler for that kind of stuff.
And yeah, it was such a nice experience.
And this was in Scala, I assume?
This is in Scala.
Right. Okay.
Yeah. But certainly things were harder because of the way that I had built the program. I wasn't using reflection-based dependency injection. Everything was statically injected basically. And so, but I was so thankful that the refactor was easy and worked without a lot of pain.
Which is not something you see up front. You see it when you have to change things.
Yeah.
And isn't that one of the, I feel like, when extreme programming and Agile and stuff came out, they were arguing that either our assumptions about where costs happen was wrong, or they should be wrong, or something like that. They were saying, well, we assume that as the system gets bigger and bigger, if you need to make a change, further down the line you are, the more expensive it is.
Yeah.
And I can't remember if they were saying it isn't actually that way, or it shouldn't be that way, because it does seem like it is. The worse design your system has, the more expensive it is to make changes. And I think maybe their thing was, our goal is to have that kind of flatten out, so that if you want to make a change further down the system, it's not nearly,
instead of having an exponential curve.
Yes, exactly.
More linear or something.
Right. It's something so that, and if you think about it, well, it's almost like what Martin's doing with Scala 3 right now. He's going, oh, I have this great idea. And he's not saying, oh, but we're so far down the line, the complexity that's going to cause is prohibitive, so I can't do it.
Yeah.
And when you're building a system, you want to be able to take that great idea. I mean, this is when I put books together, I want, if I get an idea 10 days before production, I want to be able to say, oh, that's essential. We got to be able to put that in and not have it be a prohibitive thing.
Yep. And you've put together infrastructure that enables that for you.
It's going to test everything.
Yeah.
And that's why the idea of having the tiny chapters is because, I can just insert a tiny chapter at the right place, or, oh no, this needs to move around, and it doesn't have that cost.
Set up a foundation that makes refactorability low cost.
Yes, exactly. And so, because it just seems like that happens. Like the more I understand something, the more likely I am to get that insight, and it really needs to go in there. You can't just go, it's too late.
Yeah.
So,
to wrap up on the making your types reflect reality, what spurred that idea was a video that I watched from the Scala Zio conference, where somebody was presenting on, I think his name is George or Jorge, presenting on Scala Zio Prelude refinement types. So it's a new feature in a library called Zio Prelude that adds support for refinement types, which are a way to essentially easily have your types reflect reality for some type of types, but do it without runtime overhead. Because a lot of times to do this well, you have to wrap things into new classes, which is more allocations, blah, blah, blah. So the refinement types that are coming in Zio Prelude look really nice for doing this.
Right. And what you were showing me indicated that if something could be checked by the compiler, it would be. And if it wasn't possible, then it would add some kind of something in the constructor to test the type when it was being created.
Yep. Yeah. And this specifically, there's, can you apply constraints on your type? Like, let's say you have a name and your name shouldn't be empty.
So then preconditions.
Yeah. And so it gives you a nice programming model for dealing with those preconditions, But there's times when you have a value at compile time, which should be able to be checked at compile time, and Prelude does that. But then if you have a value at only at runtime,
say something you're pulling
or whatever,
out of a database, right?
Then it still will check that constraint, but will then give you back a type that is an either, a sum type that says either, yes, this is the value of this thing because it passed the constraints, or an error.
It's kind of mind-boggling because you're saying if it can check it at compile time, it doesn't give you an either because,
right.
I mean, which logically makes sense.
Yeah.
But when you think about, oh, how is it doing that? When if it has to check it at runtime, it does give you an either.
Yeah.
It's like, huh.
Yeah. Huh.
That's
pretty amazing. Scala macros.
Yeah. Well, I remember hearing people say, oh, Lisp macros, that's like a whole different world. And my exposure to macros was like C and C++ macros, which were simply text replacement, nothing very terribly sophisticated. And then you go, well, why is this so complicated? It's because the term shouldn't have even been used in the same way.
Yeah.
And so, when you see, well, and didn't Dick Wall use Scala macros for his dependency injection system?
I think he used a compiler plugin.
Oh, you're right. It was a compiler plugin.
For some reason, people in the Scala community don't typically use compiler plugins anymore.
Well, I think compiler plugins were a precursor to macros.
Probably.
Yeah, because I feel like he said at some point that, now
maybe he did switch to a macro.
You would do a macro or he switched to macros or whatever.
Yeah.
So,
so dependency injection, I don't recommend it. But the alternative that I do recommend, effect systems, there's a learning curve too. So, and we haven't really seen effect systems, at least that I've seen, like in the world of Java. They do exist in Kotlin. So Arrow, the functional programming library in Kotlin, actually has some effect system stuff in it, which is pretty nice.
And is there some limitation in Java that prevents an effect system?
I don't. Maybe the programming model just would be
make it too complicated.
Make it too awkward. But it seems like people that are interested in that way of doing things are
moving to a more Java. Appropriate language. Yeah. I see.
Yeah. Well, that was fun.
Yeah. I learned some things.
Me too.
It's kind of an interesting, especially stuff where you know a whole bunch and I know nothing. I get to pretend to be a proxy for the audience so I can hide my own ignorance about. I'm just asking this question for the audience. It's like I understand all this stuff, but I actually don't.
Asking for a friend.
Yes, exactly. I'm asking for a friend because don't understand this. So I get to ask all the most basic questions.
Yeah.
Yeah.
That's fun.
It is. Thank you.
Thank you.